All right, hi, so this is going to be part 2 of kind of our big lesson on the binomial theorem, and next we're going to be looking at some binomial experiments. But first, let's recall what we learned in using the binomial theorem in the expansion. So the total number of terms, once I'm done expanding and multiplying, that's really what expanding means, is multiplying it out, is I always have n plus 1. So remember that n is the exponent that I have with my binomial. The exponent of a in the first term, remember, it was n, and the exponent of b in the last term is n. So as we go from left to right, the exponent of a decreases, so it gets smaller and smaller, while the exponent of b increases from left to right. So the sum of the exponents, when I add those exponents together, I will always get n. So the coefficients are symmetrical. See if I can spell. And they follow the nth row of Pascal's triangle. And remember that if you can't remember the triangle or you don't have one with you, you can always, using our combinations that we've learned, find those coefficients. So you'll always start with finding combinations. So this would be our n value, n0, and we would work our way to the combination of finding n, taken n at a time. So we can always do that or use Pascal's triangle. So now we're going to take a little bit of time and look at some binomial experiments, right? So not just using the binomial theorem to expand our polynomials, but now looking at some experiments and what those mean. So a binomial experiment, I want you to think bi means two. So a binomial experiment has two outcomes. It's either a success or it's a failure. So success we qualify as P, and failure we look at as Q. So the probability of our successes is going to be P. That's how we're just going to look at it. So the probability of failure is going to be Q. The other way we can find that Q is take 1 minus P, right? Because remember, our probability lands somewhere between 0 and 1. That's kind of what probability tells us, is that we are somewhere between 0 and 1. So let's look at this example. So here's my experiment. I'm randomly selecting a month 30 times. So I randomly just pick one. So a success would mean it would be January. Failure would be it's not January, right? Because remember, we only have two options with these binomial experiments. So a success would be there are 12 total months and one of them is January. So our Q would be 1 minus that whole P, or knowing this, we also know that there are 11 months that are not January. Okay, so we're going to randomly select a card 100 times. So a success would be a heart and a failure would be not a heart. Well, when I'm pulling a card, I know that a quarter of them are hearts. So that would mean that 3/4 of them are not hearts, right? And I could do that and subtract it again. Okay, so now we're going to look at some more probability stuff. So if a binomial experiment has n trials, so now I'm saying if I do this how many times, certain times, in which P is the probability of success and Q is the probability of failure, then the binomial probability that there will be exactly our successes, right? That's the big keyword, is exactly, is here. Again, we're using our combinations. Whoops. So I find my combination, and then I take my probability raised to the r times Q to the n minus r. So we're going to look at some examples of that. So this is something you are going to want to know and have written down because we'll use it a bunch of times. So Mark tosses a coin 25 times. What is the probability that it lands on heads? Exactly 7 times. So when I see that exact, here's where I can go. I can follow this exactly, right? So my n, I first want to figure out what my values are that I'm looking at. So my n is 25 because that's how many times I'm tossing the coin. My probability of a success would be 1/2, right? Because half of the times I would get a heads. But that also means that my probability of Q would also be 1/2. And my R value here is going to be 7. And I get that because it's looking at exactly 7 times. Okay, so now I can take this information and plug it into my formula above and come up with what we're looking at. So I would have 25 C7 times 1/2. And I'm always going to use my parentheses to the 7th. times 1/2 to the 18th, right? Because that is my n minus r. So if exactly 7 times our success, 18 times would have to be a failure. So I'm going to go ahead and put this in my calculator, and you can use Desmo so you can do it all in one line and not have to actually multiply a bunch of things together. So the probability would be 0.0143. And then again, I don't really like dealing with decimals when we're talking probability, so I move my decimal, so it would be 1.43%. So let's look at this example right down here, number 3. So Kate took a multiple choice test with 4 choices for each question. If she guessed the last 5 questions, what's the probability that she got exactly 3 questions correct? So my n value here is 5 because we're guessing on those 5 questions. My probability of success would be a 1 out of 4 because each question had 4 possible answers and one of them would be correct, meaning that a failure would be 3 out of 4, right? Because 3 out of the 4 of my answers would be wrong. And my R value, R would be 3 because I want exactly 3 correct. So then again, I can just rewrite this out. So I've got 5C3, and my P value is 1/4, and exactly 3 times. And I would have a failure then 2 of those times. So again, I put this into my calculator, and I come up with 0.0879, which again, if I turn this into a percentage, it would be 8.79%. Okay, so now I want you to try these other examples and see if you can follow along where we get our N, our P, our Q, and our R. That's the first step. So now what happens if I don't say exactly, I say at least or at most, right? Those are things we can look at as well. So we're going to do something very similar. So Kyle tosses a coin 10 times. What is the probability that he gets tails at least 8 times? So that would tell me that my R value would be 8, 9, and 10. Okay, because at least would be 8, 9, and 10. So I'm going to actually do all of those things separately. So I've got my 10C8 and my success, and right, we're tossing a coin, so it would be 1/2, 8 times 1/2, 2. And then I would also have to look at, well, if I got it exactly 9 times, this is 1/2, 9, and 1/2 to the 1. And what happens if I would get it all 10 times? Okay, so I would plug all of these 3 things into my calculator, which would give me 0.0439, 0.0098, and 0.0010. I would then add these up because all of these probabilities would fall under my at least 8 times category. So I would end up with 0.0547 or 5.47%. Okay, so then I can use these words to help us. So I'm going to be doing the same thing, I just sometimes will have to do it more often. So let's look at number 11 together as well. So the soda company prints prizes inside their bottle caps. The probability of winning a prize is 1 in 3. Out of 8 bottle caps, what is the probability that at least 5 are winners? So I would have to look for it 5 being a winner, 6 being winners, 7, and 8. So I'm going to go ahead and look at all of those things. So I see I've got my 8C5, and the odds of winning are 1 in 3. So that means that the odds of losing are 2 out of 3. Okay. Well, and then I have to see my 8C6. My odds again of winning are 1 out of 3. And that's a 6. And that's a 2. Well, then I have to see my 8C7 and my 8C8. Okay, so when I put these in my calculator, right, I would just find my combination or use Desmos or your calculator, and then 1/3 to the 5th times 2/3 to the 3rd, which would give me, let's write these down. So I've got 0.0683, 0.0171, 0.0024, 0.0002. So now that I have all of those, I just add them all together to come up with my overall probability. Ooh, that's an 8. Those are both 8s. Or if I want to write percentage, I would have 8.8%, right? And so this we can just look at each little piece individually and then see where it falls. So what I'm going to be doing now is I will go through and finish up the rest of these examples. I want you to do the same thing and then check your answers to make sure you're on the right track. And as always, come find me when you get stuck or let me know when you have questions on anything. Thanks, guys.